Good morning.
Good morning.
Thank you. Was I really loud when I said good morning? Did I wake everybody up? Okay. My name is Craig Fox. I'm with ETC, and today I'm with Leducation. I know that because I have this thing on my lapel. Before we get going with this excellent presentation by Con Ed, a couple of housekeeping things. We have a speaker evaluation that can be found online at leducation.org, which we would be really happy if you would go online at some point in the future and rate the presentations that you attend. It helps us to keep our bar set high with the quality of our presentations. In addition to that, if you need AIA credit, if you're an architect with an AIA number and you need credit, please stop back at the table outside on your way out and sign up if you hadn't already. Those of you who need credits will get an email with a certificate in it if you've been scanned on your way in, or on your way out if you forgot. So, Leducation would like to thank Dave Pospisil and Gabe Arnold for, stand up, we have a photo op, I didn't tell you this part. Dave, it's yours.
Thank you, sir.
Yeah, thank you. Thank these guys for their volunteering.
You didn't hear the presentation yet.
I have the boxes for you too if you want them later on.
Great, thank you.
And here we go. Dave R. Pospisil, CM Manager, Commercial and Industrial Energy Efficiency Programs, Consolidated Edison Company of New York. Really, we couldn't have shortened that?
We could have.
David is Manager of Commercial and Industrial Energy Efficiency Programs, where he oversees a $300 million program portfolio supported by a network of over 700 market partners. David has worked in a variety of positions for Johnson Controls, Public Service Enterprise Group, Pennsylvania Power and Light, and the Train Company. He is a certified energy manager and an active member of the AEE, the New York Building Congress, the Manhattan Chamber of Commerce Green Business Committee, American Institute of Architects, New York, and Urban Green Council. David is an officer of the New York City chapter of the American Society of Heating, Refrigerating, and Air Conditioning Engineers, or ASHRAE. Gabe Arnold is a program manager with the DLC, where he leads the Networked Lighting Controls program. This new DLC program is working with utilities, the US DOE, and the lighting industry to create a suite of tools and resources to support the widespread adoption of advanced lighting systems. Gabe has more than 20 years' experience in the energy-efficient lighting industry as a lighting designer, utility program implementer, consultant, and the DLC. Gabe is a registered professional engineer and is lighting certified by the NCQLP. I've taken up enough of your time. Gentlemen.
Thank you, Craig. Good morning, everyone.
Good morning.
So I'm with the DLC, and the course we're presenting here today is actually some excerpts of a half-day course that the DLC's been developing on network lighting controls, and we'll be deploying through our utility partners over the course of the next few years. So some snapshots of that course are within this, and hopefully you have a chance to attend the longer course in the future. Going to go through some AIA stuff to begin, and then we'll get right into the material. So this course is eligible for AIA continuing education credits, if that's important to you. And here's our 4 learning objectives. These are the same learning objectives from the much longer 4-hour course, so we're going to take a shot at addressing these as we can in less than an hour. The first one, want to make you aware of some new types of lighting controls that can reduce the cost and complexity of installation, a big issue with lighting controls. Secondly, want to provide you some guidance and some information about a new publicly available tool to support selecting control systems for a project or application. And last piece will be from Dave with Con Ed, who will be talking about some of the support they have available for network lighting controls. So, just a year or two or three ago, talking about lighting controls was maybe a dull subject. I tried it many times and probably bored a lot of audiences, but if you are in the control space, you're watching what's going on right now, it's anything but dull. There is a tremendous amount of change occurring, investment, and innovation. It feels a lot like it did back in 2008 or 2009 when LEDs were first entering the market. We have all these new startup companies that we've never heard of suddenly getting into the control space. We have a lot of venture capital coming into the space. We have large multinational corporations that have never been involved in buildings, much less lighting, all of a sudden getting into the lighting space. Companies like Cisco and IBM. And so what's that about? And it has to do with something called the IoT. And so this is the big buzz, of course, in lighting. So I assume everybody knows what IoT is? Yes, okay. So this idea that we've got sensors, or everything in our building is connected. We deploy sensors all over, and we're gathering this data, and we're going to be able to do things we can't even imagine with that data. So that's drawing a lot of people in, and all this new investment and innovation. So, what's it got to do with lighting? Lighting is evenly distributed throughout all of our buildings, inside all of our spaces. It's also evenly distributed through all of our cities and all of our streets. So it's kind of this perfect infrastructure to deploy this new IoT future, because these sensors that are going to be gathering data, of course, need power. They need power to collect that data, and they need power to transmit it. And so we've got lighting as this perfect medium to support that new future. So really exciting. There's going to be all kinds of new business opportunities. We had, first we had computers, and then internet and e-commerce, and then smartphones. And this is going to be the next big thing. But so we'll talk about that, but I wanted to take a moment and offer some perspective on the past here. How many people have ever been one of these people up here on the slides? If I were to ask you if you've been involved in some sort of advanced lighting control project in the past, a project that used a networked control system, unfortunately, this is the experience that many, many people out there have had. So there's our designer, maybe saying something like, how am I going to spec this job using this complicated control system in a way that is going to allow for my customer to get multiple bids because they're all proprietary? Or maybe saying something like, should I invest all the time and effort into designing with this complicated control system if it's just going to be value engineered out at the back end? Should I spend all this time designing with this complicated control system? Is it just going to cause problems for my customer later on because it's not working correctly? Or the contractor, all too often, when they're involved in one of these projects, they've been burned. How are they going to get off this job and make any money? Why are they getting called back again? Customer callbacks. How are we going to get this control system working? The facility manager, the lights are flickering or they're turning off in the VP's office, and I can't figure out how to get into the system to make changes to fix it. And so I'm just going to disable it, which of course, you've invested all this money in this control system, and when you disable it, all of a sudden all your benefits are gone. And then of course the building occupants, if you ask a non-lighting person, building occupant, what they think of commercial lighting controls, most often they do this, right? Because the systems not always work that well, or they haven't been designed, installed, or commissioned properly. For some of these reasons, we've had low adoption of controls in general, and especially advanced lighting controls. So this is some recent data from the Commercial Buildings Energy Consumption Survey. It's national data. It tells us the percent of buildings with a particular control strategy. So it's not telling us the percent of lighting that's controlled by a particular control strategy. It just says, the way to read this is 16% of commercial buildings have occupancy sensors somewhere in the building. 2% of commercial buildings have daylight harvesting somewhere in the building. So these are low numbers. You know, obviously, way more than 2% of our commercial buildings have windows in them, but we've only got this strategy deployed in 2% of them. Here's a little bit more specific data, and I know you probably can't see that at the back. This is telling us what percent of the commercial lighting is controlled by a particular control strategy. This is in the Northwest US, an area of the country that's traditionally been very green in their building practices. They've had long-standing energy codes, long-running utility energy efficiency programs and rebates, and just, you can see on this, or you can't see, I'll just report it to you. Let's look at one of these numbers. So 0% of commercial lighting in buildings is controlled by photocell. So of the installed wattage. So that's your daylight harvesting, not even registering at 1%. 1% is dimming. 8% controlled by occupancy sensors, 73% still controlled manually. So there's a number of entrenched barriers that are leading to this outcome that we're facing right now. So one, a lot of people have been burned by this technology in the past. There are a lot of, the workforce has kind of been unfamiliar with the technology and how to design with it, how to install it, how to commission it, and then once you've got it in your building, how to actually operate it. And this is exacerbated or even driven in some ways by the fact that historically network controls, advanced controls have been very complex. And that is exacerbated by the fact that it hasn't been standardized. We lack standards and we lack standardization. So we've had a proliferation of proprietary control systems on the market. So put yourselves in the shoes of a designer or a contractor, installer, and you know, how can they stay up to speed with all the different control systems on the market when they're all different? They're all installed differently. You know, many of them are proprietary. And this all kind of cascades on one another and leads to high costs, higher costs than they should be. So a contractor sees a project coming through using some sort of advanced network system, and they're adding dollar signs to their bid to cover their costs, to cover their risks, right? Because they know these systems are going to be complicated to install. They're going to need to spend time to come up to speed on how to install them, and there's probably going to be some callbacks after the fact. And of course, ultimately leading to a weak value proposition and this low adoption. So enough of the negatives. That's the bad news. Let's look forward here. And the good news is that this is all being addressed. And it's really exciting to see what's coming out from the manufacturers over the past year or two and what's going to be coming out over the next few years. The technology is rapidly improving. And the manufacturers, one thing they've recognized is that this complexity issue is a major issue that's got to be addressed if we're going to get these systems widely deployed. And they're starting to design these systems that are designed from the ground up to be simple. Simple to design with, to install and commission. I'll talk about some examples of how that is in a moment. In addition to that, of course, they're offering many new capabilities that go beyond just energy savings or go beyond lighting. So these are some of the IoT capabilities which help strengthen, by orders of magnitude, the potential value proposition. Things like asset tracking. So embedding Bluetooth into your light fixtures and Bluetooth beacons into all of your devices. Tracking assets or equipment with some types of business is a major operational challenge. So we've got hospitals in particular are starting to embed these Bluetooth into their light fixtures and then beacons into all their equipment, and they're able to know where everything is in the facility. They spend a tremendous amount of resources and money currently trying to do this. Another quick example, you might be surprised, at the Atlanta airport. So Delta is actually now using the lights to track the wheelchairs in the terminal and saving something like a couple $100,000 just in being able to know where the wheelchairs are. Another example, space utilization. So using our lights to understand where people are in a space and where they're moving, where they're congregating, when they're there, and then using that information to optimize the layout of our space. There are some manufacturers of these systems that are reporting something like $8 per square foot per, I I think it's year in savings due to this aspect. They're also using it for things like savings on cleaning, right? So you can actually look at the outputs of these systems and see when a space has actually been used, and then maybe you don't need to send a cleaning crew into that space. So there's savings in cleaning costs, which sounds like it might be insignificant, but is actually greater than the energy savings that the system can provide. Indoor positioning, there's a lot going on with this, especially in the retail space and also in airports, where we're able to use Bluetooth technology and in some cases visible light transmittance from the light fixture to understand where people are inside a building. So this is something that we haven't been able to do with traditional GPS technology. So there's all kinds of new values there, and I don't want to go through all these because I'll use all the time. But all of these are going to greatly strengthen the value proposition. So what I wanted to do here was talk about 3 of the, I think, most significant trends here that are changing the game in terms of reducing the cost and complexity of these networked advanced lighting control technologies. So the first one is integrated or embedded sensors or controls. Everybody's probably seen this trend, right? So up there we've got a high bay fixture, we've got a downlight, a couple of different high bays, we've got troffers, and we're going to start to see more and more fixture types that are becoming available with this type of architecture. So what it is we've got a daylight ambient light sensor and an occupancy sensor, and it's embedded directly into every luminaire. So on the surface, people first see this and they think this has got to be expensive, right? Instead of putting one sensor in a room, you're all of a sudden putting them in every light fixture. Does that make any sense? Well, there's some tremendous advantages to this type of architecture. A lot of it has to do with reducing the cost and complexity of install, so the labor cost to install. So first of all, one benefit is pre-installed means you don't have to install them. So if the fixtures are shipped with these sensors embedded in them, the contractor, of course, doesn't then need to wire up or connect some type of sensor. Secondly, they can be pre-configured for out-of-the-box functionality. So what historically has been a relatively manual process in laying out your sensor and determining which light fixtures it would connect to and doing some commissioning to make it work properly is potentially going to be replaced with this type of architecture with basically a pre-configured out-of-the-box process. So install your light fixture, it's pre-configured, ready to go, your occupancy sensing is ready to go. There's no extra work to do there. Fewer components, right? So we used to take an occupancy or a daylight sensor, we'd install it somewhere in our space, might need a power pack to wire that up, might need control wiring between that and the luminaires you're going to control, or control wiring back to your lighting control panel. That's a lot of different parts and pieces we've got to make work and connect. And so when we start to do this integration of the sensors in the fixture, we have fewer components and potentially a single warranty. So if you've ever been involved in trying to get a warranty on a lighting project that had problems, it often becomes this blame game, right? So it's the fixture manufacturer, no, it's the driver or ballast manufacturer, no, it's the lamps, no, it's the installers, and so forth. But when we've got it all coming from one place, I guess there's fewer places to point the fingers. No control wiring, which I already mentioned, and eliminates this task of figuring out where to place the sensors. So let's compare and contrast daylight harvesting using traditional methods versus this method here. So when you're going to do daylight harvesting in the past, you'd have to go through this process, figure out where you're going to put your daylight sensor. So it's going to measure the amount of daylight coming through the window correctly. If you've ever done that, that is not a trivial task. It's not easy to do. And then you had to decide which fixtures it was going to control. So are you going to do just the ones in front of the window? What about the ones that are just off to the side a little bit? You're going to do just the first row or the second row? And then how much are you going to dim each one, each row or each group? You're going to have multiple zones. And then what's the process to commission that so that it dims correctly for the amount of light you have in space and you're maintaining the right amount of task illuminance that you want? that is a very complicated task, and it often doesn't work. So, you know, you go out to these projects where you've installed daylight harvesting, and the utilities have done this quite a bit, where they've provided rebates, and they find these systems aren't working. And the customers have spent a lot to put those in. Now, contrast that with these systems here, where you have the sensors integrated into the light fixture. So, so the manufacturers, they, you know, for a troffer, for example, they know in 95% of the applications that mounting height's going to be 8 to 10 feet. They have a good idea of what is going to be in the space, offices, and so they can pre-configure those sensors, integrated sensors, for that space, so that they basically are going to work right out of the box, work pretty well, and provide you that daylight harvesting without all this complicated work you used to have to do in the past for daylight harvesting. So this is tremendous potential benefit in reducing the complexity of doing daylight harvesting. So, you know, what's often brought up is this is going to be really expensive, as I mentioned, but there's another trend that's going on out there where the sensors are being miniaturized and the cost is coming down significantly. And so we're approaching a crossover point or an inflection point of sorts where if you look at the total cost of the installation labor plus the equipment costs, an integrated system like this where you've got all the sensors in every light fixture can actually cost less than the traditional means of one sensor in the room and the manual process you had to do to configure that. Not true with every manufacturer yet, but it's slowly becoming true. Another challenge, of course, is limited fixtures available. And you know, what are you going to do with your cove lighting, for example, some of your decorative lighting, your accent lighting, and so still some things to be figured out, but this is a really promising trend. Second one, this one's a little bit more obvious about the benefits, but I want to point out another aspect here. So wireless, of course. There was a tremendous cost in the past with these network systems and running all that control wiring. It was also a point of failure. And so with wireless technology, we can eliminate some of those challenges. But there's another benefit here to wireless, and that is that with these wireless systems, the way they tend to work is every light fixture and every device, sensor, or switch gets its own address. And so instead of relying on how the components are wired to determine your zones, to determine which groups of light fixtures will be grouped together and which switch should control them or which occupancy sensor, instead of relying on your wiring to do some of that, they're relying on programming them, right? Because every device has an address, so we're using like an app or something, something like that to group our light fixtures. And this is a huge benefit for the long-term operation of these systems, longer term. So I talked about the challenges of people being able to make changes in these systems over time. So what happens if the zones of or groups of your light fixtures that were determined by the specifier or contractor at the beginning don't end up working out for the customer, and they want to change which fixtures are connected to which sensor. Maybe they want to remove a fixture. Or what happens when something changes in the space, we reorganize a desk or something like that. With some of these older technologies and older systems, we had to rewire them. And so what would happen is we would disable them instead. What we're talking about here, because every device has an address, we can just go in at any time and pull up our app and regroup our fixtures. And that's the third trend here, which is this move to apps or software tools to configure our lighting. If you've ever looked to make changes with some of the traditional lighting controls, let's say you wanted to change your occupancy sensor time delay. How do you do that? That was a very complicated process. You would a lot of times have to dig deep into the website to find the manufacturer's literature, read through all the small print, and you would find these instructions, and it might say something like, hold down this button for 8 seconds, and then you'll see 2 LED flashes. Push the button 7 times, and you'll see 6 more flashes. Then you would enter the time delay mode, push it 3 times to get to 30 seconds. So this was just complicated, and people often didn't do it, and again, we disabled it. So now we've got these intuitive user interfaces with apps that allow us to go right in, pretty intuitively find the setting that we want and easily change it. So we've all gotten used to these interfaces with our smartphones, and so now we're starting to apply that to lighting, and it's a huge change. So here's one example from one manufacturer, and this is, you know, when you're doing the startup or commissioning of the system, you know, you walk into the space, it's listing your light fixtures by order of signal strength, so you're likely to see the ones that are just in that room. You flash the button to identify which one, then you drag it into the group. Drag all the fixtures you want in a group, and then you drag the sensor in that you want to control those fixtures. You know, that's where we're headed. Here's another manufacturer that's basically doing the same thing. And we can't say manufacturers' names here, but I like to show this because it's great to see some similarities in what the manufacturers are doing. It seems like this type of approach where you're listing your fixtures by signal strength and you know, flashing them to identify and then dragging to group or clicking to group them seems to be taking hold with multiple manufacturers. The scheduled programming becomes much more easy and so forth. So this is an exciting trend. I need to caveat it that it's new. And so this is going to be a challenge, right? Because contractors are used to the older methods of grouping and zoning fixtures, not used to smartphones. So it's going to take some time before this really starts to be adopted out there. But the benefits are tremendous. So kind of the way we used to do things with manually laying out sensors, manually grouping zoning, all the work we had to do with compatibility between all the devices, the work we had to do to make sure daylight harvesting was working correctly, the low voltage control wiring we used to have to run between things, which was expensive to do, and the complex commissioning process are being potentially replaced in this future by all these automated and much simpler processes. I'm going to move more quickly. I think I'm using a lot of my time. Another big trend that's out there with these systems, which certainly we're excited about with the utilities, is this integrated power meters. So we used to think of meters as being, you know, those things that go on buildings and the utilities use for billing purposes. And what's happened is that some of the electronics companies have come out with little tiny metering chips that we can integrate directly into our lighting equipment, and very inexpensively. So these things are, you know, less than $1 each. And that's going to open up all kinds of potential opportunities, some of them related to IoT, some of them a little bit different in terms of being able to use that energy data for things like lighting as a service. Perhaps you've heard about that, to really expand the use of performance contracting, to support new types of business models, financial models for paying for lighting, leasing, based on the performance. When we've got this data that shows the performance of the system, we can start to do all kinds of things that we haven't done in the past. So I'm going to shift gears a little bit here, and what we do with the half-day course is we go through all the different types of control systems, and we kind of compare and contrast them and look at some of the pros and cons of each. I don't have time to do that today, so I'm going to skip right through to the bottom two systems. There are simplified network systems and comprehensive network systems. So these are some of the new types that the utilities are targeting for the future here. And what I'm going to do is put these in two different buckets. Now, if you looked historically, network lighting controls were a complicated technology, and they tended to fall into that bucket there on the right side, the comprehensive systems. What's happened is the manufacturers over the last year or two and going forward have started to develop a different variety of these network systems that we're calling simplified, that are much simpler and easier to use, and have kind of a basic feature set which kind of opens the door of this network technology to a much wider universe of customers. The network systems, they used to be really just for customers that had, you know, large budgets to work with, owner-occupied type spaces where they'd really see the value, that had facility management teams that could operate the systems. And so now we've got some network controls that can work for customers that don't have deep pockets, that don't have facility management teams. Maybe they don't even have a facility manager, and maybe they even lease the space. And so I want to kind of dive into these two different types. So characteristics between the two. So simplified network system tends to offer out-of-the-box functionality, whereas a comprehensive system is customized by application. Some of these new simplified network systems don't require a computer server, any type of central gateway, or a cloud internet connection. We've typically associated those with network systems, but there's these new network systems that don't require those things, whereas a comprehensive system typically requires a computer server or cloud internet connection. Simplified systems are designed for simple commissioning just by the contractor. Some of the comprehensive systems on the market are designed to have the commissioning done by the manufacturer or with support of a trained manufacturer's representative. Simplified systems they're designed not to require a sophisticated facility manager or some sort of trained third party to manage the system, whereas the comprehensive network systems are really designed, you really need to have a facility manager that's well trained on the system to operate it. These simplified network systems that have come onto the market offer kind of this basic control strategies: occupancy, daylight, high-end trim. And the comprehensive systems add a lot of additional capabilities such as scheduling or demand response. The simplified systems are designed for a single room or building applications, whereas the comprehensive can support a campus application or enterprise where you've got buildings all across the country. Some of these simplified systems, in order to make them simple and less costly, they tend to be wireless. They may have these integrated sensors that I talked about before, whereas the comprehensive systems, they may also have some of those features, but they go much beyond that and maybe incorporating some of these additional IoT features. So it's useful to kind of characterize the systems these ways, because when we're out there and we're trying to determine what type of control system to use with a particular customer, it is not one size fits all. And so these kind of buckets are really helpful to think about when you're looking at that particular project. So because this is an AIA course, I was not able to put the manufacturers' names in here, which kind of helps to bring this home and make it real. So I can't do that here, but I'll say that most of the major lighting control companies they're all kind of moving this direction. They've got now a simple network system, wireless integrated sensors, and then they've got their traditional complex network systems. So next time you're looking at what systems are available from some of the major control manufacturers, you can check that out. There's really two different types that are becoming available now. There's another trend which is happening out there, which is interesting and I think overall a good thing. I think one of the things that have made the adoption of, that have really made this technology so complex in the past has been the fact that manufacturers have offered so many different options. So between all their standalone controls, their various relay panel options, to their network systems, from their sub-brands, all the different sub-brands that some of the large ones use, it makes a user's head spin. How do I know which one I'm supposed to use on a project? So there's this other trend that's happening out there where manufacturers have kind of recognized that as an issue, and there's a couple of manufacturers starting to offer systems that can be very simple, or if you want, you can add some components and make them complex. So for example, there's a system that's on the market right now where it's networked and it fits in this simplified bucket if you just install some light fixtures in the room with integrated sensors and a wall switch. And it's all networked together. You program it with an app, simplified. You add a gateway to that system, and all of a sudden you have the ability to do scheduling, demand response, energy monitoring and harvesting, gathering the energy data, opening up IoT applications, adding in the positioning thing. So this is, I think, overall a great trend that's going to reduce kind of the confusion out there around these systems. All right, last part, and then I'll pass things on to Dave, and I wanted to make you aware of a new publicly available resource from my organization, the DLC, to help you in this system selection process, to help you understand what systems are out there, which ones are simplified and which ones are comprehensive, and really support you in choosing these systems for the project. This is a new qualified products list that we have, and it's not just for this to choose a system that's eligible for rebates. It serves this whole other purpose in helping you kind of make sense of the products that are out there. So just a quick snapshot of this, and I know you all can't see this, but right now this is in Excel on our website, and there will be a web platform that'll be rolled out later this year that'll be searchable and downloadable. But even with the Excel version, we offer the ability to filter and compare the systems. So there's one page there where you can filter and compare the systems by the scope, the warranty, whether there's case studies available, and so forth. And I've got all the manufacturer names kind of blocked off there. Right now we've got 16 systems on there. And so you can find systems that are just for room level, some that are for building level, and then some that are for enterprise level, for example. We have another tab where you can filter, compare, identify systems by their capability. So this screen's kind of small, but so what we've got, which systems are wired or wireless or both? So you can, which systems have occupancy sensing, daylight harvesting, high-end trim, scheduling, personal control, demand response? Which ones can control plug loads? Which ones have the integrated sensors? Continuous dimming, energy monitoring, which ones can measure actual energy use to meet some of the new M&V requirements of energy code? And then there's a third tab which really lets you to get into the details. And so you can expand the scheduling tab, compare all the different systems that are qualified on the market, which ones have astronomical time clock functionality, which would be important if you're controlling outdoor lighting, for example. Demand response, which ones are open ADR compliant. So this is a standard for demand response that some utilities are subscribing to. What types of dimming control do different systems offer? So proprietary digital, so this one does 0 to 10, forward phase, reverse phase, proprietary digital as well. This one's only 0 to 10. So these are important characteristics when you're thinking about which system you're going to select on a project. Which systems can tie into your other building systems, your HVAC system, and how can they do that? Through BACnet, or are they only offered a closed contact switch? So this is a new resource that we've developed that is now available to the whole market to use, and we'll be continuing to evolve it to try and address this issue of the market really being really confused about these systems, and trying to make this resource that people can easily compare and identify particular systems for their project. And so over time, you'll see the utilities start to require this more and more, or really encouraging their customers more to use one of these systems to access the rebates. So with that, I will pass things off to Dave with Con Ed, one of our partner utilities.
Thank you, Gabe, and good morning. I guess I have a few minutes left to do my 50 slides. No, just kidding. There's very few. But for those of you who are from out of town, Con Edison is the local provider of electric, gas, and steam to New York City and Westchester County, which is up to our north. And we've been involved in energy efficiency and demand management for many years, but our current phase of programs is we're about 8 years into that now. So if you're following at all what's going on in New York, we're in the midst of a transformation of the electric grid, of the energy business, and it's called Reforming the Energy Vision. So really there are some very aggressive goals that are being set that this new transformation is trying to meet, and it's reduction of greenhouse gases, clean energy generation, and a decrease in consumption by buildings. If you've seen, New York is kind of upside down from other cities where transportation contributes much less to greenhouse gases and carbon emissions than buildings do. So in New York, we're almost 80% of our carbon emissions come from buildings. So we have a big impact when we decrease the energy usage or make it more efficient in buildings. So those goals are 2030, and we're getting there pretty quickly. So we talk about rev-ready buildings, and when you talk about, we used to hear about when apps just started to become kind of in the public eye, people talked about killer apps, and from our perspective, what Gabe just talked about is a killer app in the building science business, and it's evolving quickly. So we're looking at buildings where network lighting system can provide a basis. You cannot imagine how many we've had pretty decent penetration in our building stock with the last 8 years of our programs, but you can't believe some of the buildings that are still out there that are T12, and the level of sophistication of controls is there's a time clock maybe. So we're looking at this as an easy way to introduce some level of control, some level of efficiency, and as a foundation that you can build upon. So these systems are very interesting to us, and we are very focused on pushing them out into the marketplace. And why is that? So we have some backup here. This kind of shows the curve of the potential for energy efficiency. And actually, the DOE says that about 1/3 of this efficiency is driven by the penetration of connected LEDs. So the LEDs, just the pure energy savings, have really driven a lot of what we did. But now the integration of controls and the networking of those controls, especially we have many customers that are portfolio owners or managers. So the ability to manage your enterprise with this much lower investment than it used to be with hardwired communications wire and whatever else. You just plug this in, hit it, do a Zigbee initiation, and bang, you're there, right? So 1/3 can come from LEDs, and this shows where we are. So the good news is it shows that we have lots and lots of potential going forward, right? So in 2015, and we can vouch for this in our territory, that less than 1% of existing buildings now have mature solid state lighting products, right? And we just ran $116 million demand management program, and we had a bunch of lighting projects in there, and we had a big two that were integrated with controls, right? So we said, this is wrong. We got to figure out a way to change this. So we are hoping to push those numbers and accelerate those numbers through education and incentives going forward. And so these are the two that were in that program that's just winding down. So they had very good savings, right? We had 240 kW reduction in one building, just under 100 kW, some decent, great kilowatt hour savings, and paybacks, from 7.65 years. It's a owner-occupied building, so they are making an investment. They expect to be there for a long time. So good investments, but the economics are changing so quickly, and we're hoping, we're pushing incentives to kind of push those projects into the economic threshold area where it makes it easy for people to make a decision to move forward with them. So we're looking at this. If any of you were involved with communications and the whole revolution, we kind of look at this as something very similar and a similar level of disruption as voice over IP. So that kind of changed the world from hardwired phones at every desk to being able to use one infrastructure. You don't need a telecommunications infrastructure and an internet infrastructure and all these other things. They all work off the same backbone, right? And that backbone now, it doesn't have to be the traditional HVAC-based controls. Every room in every building in this city has light fixtures in it. And if we can integrate controls into them, and Gabe did a great job of describing how once everything has an address, it really doesn't matter how it's wired. It matters how you then configure it, right? So using that common backbone, we can make these buildings work in ways that people just threw up their hands and say, how am I going to do this? You know, these lights are on that bank of circuits, and I just can't make it work together. So we can change that, and we're getting to a point where we can change it quickly and cheaply. And one of the real interesting things is that the big companies from different areas. So it's not your traditional building automation system providers that we've known, and they've had proprietary systems for 100 years. But we have technology companies that have recognized that this is something with huge potential. They see those numbers too, that less than 1% of buildings have the start of putting these in here. So, oh, this actually says Cisco. Do I get? But they're one of many, and Gabe's qualified product list has a whole listing of companies that have already approved products that are kind of plug and play. Some of these products you need one person on site. They commission it through the cloud, and they just need somebody to verify on site. Okay, so did this turn the lights on in this hallway? Yep, it did. Okay, good, we're done. So we are actually providing, we just modified our commercial and industrial programs, and we've added, first of all, we changed them in the years prior. It was almost 90% of our lighting projects were custom, so they were based on performance. We were actually spending a lot of time checking LM79, LM80 test data, so we didn't really want to be a certification authority. We really wanted to help customers move products and move new technology into their buildings. So all the products that we provide incentives on now have to be on the qualified product list from DLC. And we're actually, so in this case, we're talking about fixtures, we're talking about sensors and fixtures. Our new incentives will give a customer $10 for a fixture and $50 per fixture for controls and sensors, whether they come in the fixture or they're integrated as a kit on site. So we have folks here that can give you more information on how that all works, but we're really excited about the technology, about taking those buildings that haven't participated in the last 20 years of energy efficiency and helping to bring them on board at a time when we can automate those buildings in a very quick and less expensive and get them online to energy savings. And I think that's it for this presentation. So I think we're going to take some questions, and I'm not sure if we have somebody to do that for us. So maybe if you have a question, you could just tell us who you'd like to direct that question to. Yes.
I have a question for Dave, and it's about your killer app. I mean, I've not used it. So traditionally, if I'm designing a retail space, and I have display lighting and decorative lighting and stuff like that, and then after I design it, it's executed. Now the user has the flexibility to reconfigure the lights. And when they change the grouping of the lights, how does it affect in terms of energy code? Because when I'm doing sound check, I like designate this particular lights for display, this is for decorative, and stuff like that. So when they do.
Yeah, and the question was how does the potential reconfiguration of lighting by the building occupier or manager, how does that impact its compliance with code? And I'm not really sure that the code has caught up to that yet. I'm not sure if we have New York City Energy Code experts here, but I think the code speaks to having the controls integrated into the system and having some commissioning, but I don't believe it gets down into the weeds on, so how are you controlling each specific application in the building?
It would be a nice feature if your app says, oh no, you can't combine because you've already, like these
Right.
lights
Well, with all of this data getting sucked up into the cloud too, right, into some big analytics engine, I would imagine that at some point the manufacturers are going to be coming back to the buildings and saying, well, you know, I don't know what you did, but you're not optimized anymore, and so what did you do, and how can we help you get back in the zone where you really want to be? Thank you. Yes.
So does it mean that a big building would have a big phantom load because all the fixtures are sort of on even when they're off? Because the sensors have to be operating?
They will be on. I mean, there's still the ability to shut off those fixtures, right?
Yeah.
At the address?
Occupancy thing,
Right.
something's on reading something. So if everyone is got energy going to it, so it can pick up information even when the lights are off.
Right.
It means there's
Yep.
still a big.
Yeah, there's still, I think that the reality is that load is much smaller than if the typical lighting load wasn't controlled like we have in so many buildings now.
Yeah, we've started collecting some data on that, and in most cases, it's much less than a watt. We're talking about half a watt or a third of a watt from systems, but nevertheless, it's
Per square foot or half a watt what?
per fixture. Per fixture that's basically standby load in order to keep the communications going. So it's not much, but absolutely, it will become an issue. And you've already started to see some standards in California where they're saying that this standby load needs to be less than a watt. And I think over time, as this stuff starts to proliferate, we'll probably see more and more standards, more and more push to make sure that load is minimized. But I think that the benefits and energy savings you get from these controls is greater than what that load is.
Yeah, and we don't want to get in the situation that we got into with set-top cable boxes, right? Where they're sitting there doing nothing and consuming lots of energy.
Yeah.
Anybody else? Okay, well, thank you. Oops, sorry, there you go.
In the collection of data through these integrated networks, who typically takes that information and acts upon it in some fashion?
I think it really depends on, you know, in New York City, there's some very complex and convoluted relationships between who owns the building, who runs the building, who has building data, who's the consultant. So it really depends. We're hoping to have it set up in a way where that feedback comes back to whoever has the authority to change the operation of the building and to optimize it as time goes by or operations change or whatever else. But it really is, there's a wide range of how those things work.
Yeah, and it's still being figured out. I was just at a conference last week where there was significant discussions around this issue, and you know, what was proposed is we probably need to develop some sort of standardized data agreements that specify who owns the data, you know, what aspects of it can be shared, and with whom, kind of as we move forward with this technology. So I think that stuff will be taking shape over the next couple of years. It's not figured out yet.
Yes, sir.
Can you comment on how circadian and tunable lighting kind of factors into the incentive and the control complexity?
Well, the controls are really kind of open-ended. So like we spoke about the code, not like getting down in the weeds, the incentive is not necessarily down in it. It's like if you're putting sensors and controls into a lighting fixture, we'll give you an incentive towards it. And there are some applications that we talk about, like daylighting and some other things. But I think we'd like to talk to you about what it is that you're trying to accomplish and see what that incentive looks like.
DLC has a program to look at tunable lighting and to see if you can certify that and qualify those for incentives. I don't know if you often follow that.
Yeah, we're working on a policy right now to be able to qualify color tunable luminaires. And then on the controls qualified products list, we're proposing to start adding a characteristic to identify systems that support color tuning capability, circadian tuning capability. And you know, that's one of the issues with that capability of control systems is that we don't have standardization of it yet. And in order to really deploy that and deploy it effectively, you really need to have an interface that supports it in a standardized way. So one of the things we'll be looking to do with this qualified products list is basically identifying, I'm just explain this in a short way, identify systems that support that function well in a simplified way. So I guess one example of this, so we have luminaires that are now available with color tuning capability. So how are you going to control that, right? Because you're going to want to be able to dim the light in terms of the light output, and then you also want to be able to control the color temperature of the light if we're talking about white tunable. And so what type of interface would you do that with? The problem we have right now is that there is no standardized interface, and all the manufacturers are doing it differently, but we're starting to see some standardization take shape where you would have kind of two 0 to 10 volt outputs from your control system to the luminaire. One controls intensity of light, and the other one controls the color temperature of the light. And so that's a good way to do it. It's very understandable by the user. And so we want to start to identify systems on the list that do it that way. And when we start to identify those systems and kind of try to push the market in that direction, that also has the benefit of communicating to the luminaire manufacturers how they should design their luminaires to take that control signal.
One thing that I will mention is while I said that we had changed our lighting program to be primarily prescriptive, we do still have a custom path, and it's really based on lighting power density. So if you're gonna completely reset the ceiling grid, if you can show us, if we can sit down and look at how the new grid is going to compare to code in terms of lighting power density, we can give you an incentive based on the differential in the kWh that's computed for that area. Okay, thank you very much for your time.
Thank you.